Okay, in this video, let's discuss section 5.4, polynomial and rational inequalities. Okay, so the first part, we solve polynomial inequalities. Well, first let's recall how we did for the quadratic polynomial. We know the graph of quadratic polynomial is like this, either a positive, or a negative. And then when the graph of the function is below x-axis, this part is a solution of a quadratic polynomial less than 0. The left and right branches are solutions of a quadratic polynomial quadratic inequality greater than 0, right? Greater than 0, a greater than 0 just means it's open up like a v. This is opposite v. And this is not part of an inequality. We're talking about ax squared plus bx plus c. Ax squared plus bx plus c. This is inequality. This part, the inequality greater than 0. The other two branches, inequality is less than 0. So the whole discussion depends on the graph of the function. This is a graph of a quadratic polynomial. If we have a general polynomial, in general, we don't know the graph of it. So we cannot memorize the graph of all polynomials. But we have an idea. The graph of the polynomial is like this, up and down, stuff like this. It will be either this way or the other way, whatever, like this, something like this. So it's always like this smooth curve, go up and down. Sometimes it crosses x-axis, sometimes it does not cross x-axis, more or less like this. Okay, so for example, if we choose this piece, then if the graph is above x-axis, like this like this part or this part, if the graph is above x-axis, then the corresponding x interval will be the solution for the polynomial for the inequality greater than 0. If the graph is below the x-axis, like these two branches, these two parts, then the corresponding x coordinate, x interval will be the solution for the polynomial inequality less than 0. So above x-axis, greater than 0, polynomial inequality greater than 0. Below the graph, below the x-axis, graph below the x-axis, it corresponds to the polynomial inequality less than 0. So this part greater than 0, this part less than 0. And greater than 0 or less than 0, they are always separated by 0. You see here? 0 is like the cutting point. It's like cutting point. Okay, so this is the general idea behind the solution of a polynomial inequalities. So we will do the almost identical step, but with one modification. So example, solve this x plus 3 times x minus 1 squared greater than 0. We solve this. How do we solve it? How do we solve the quadratic inequality? We first find the zeros. Like we first find the cutting point. Find the 0, we apply the zero product rule. Zero product rule means a product is 0 if and only if one of them is 0. So you get x is negative 3 or x is equal to 1. This one is a double root. Okay, so you have two solutions. Two solutions, negative 3 and 1. You see here you have three solutions, then you will get this branch, the middle branch, left middle branch, right middle branch, and a right branch. So you have, for this graph, if you have a 3 zeros, you get 4 set intervals. If you have a 2 zeros, you get 3 intervals. Well, this curve, this part is not part of the curve of a graph of function. This is not a graph function. I just want to use this curve to represent we have 3 pieces. Okay, this is piece 1, piece 2, and piece 3. Okay, so far, we first get solutions of equation about this polynomial. And then we label those solutions of equation on the number line. And those solutions will divide the number line into several pieces. Here we divide it into 3 pieces. The thing is, that's all I know so far. I don't know the graph will be up, down, up, or what else. I have no idea. So how do I know how do I know the graph is this way or the other way? How do I know it, right? Well, to determine that, we are going to use test point. First we do this, and second, test point. We're going to pick up test point from each sub-interval. We have 3 sub-intervals, so we're going to pick up 3 test points. Okay, and of course you're going to pick up simple test points so that you can easily evaluate. So I'm going to, on this left branch, possibly I'm going to pick up like negative 4. Negative 4 is a test point to test what? Test the value of this function. So you let x be negative 4. You get a negative 4 plus 3. And negative 4 minus 1 squared. I want to know the value. Negative 4, x equal to negative 4. Negative 4 plus 3 is negative 1. Negative 4 minus 1 is negative 5. Squared is 25, so it's equal to negative 25. So it means at this point, you get a negative value. Negative value, I'm going to draw it this way. Below the number line. Number line is the x-axis. Okay? Draw it this way. And then between negative 3 and 1, I possibly will pick up 0. Remember, we always just pick up simple one. You will not pick up 3.14 or like 0.1235. That's too complex for you. You don't make yourself trouble. So I will pick up 0 in the from the middle interval. So when x is equal to 0, you'll get a 0 plus 3 and 0 minus 1 squared. 0 plus 3 is 3. 0 minus 1 is negative 1. Squared is 1. So 3 times 1 is 3. It's positive. Positive means the graph is above x-axis. So I just use straight segment to demonstrate. From negative 3 to 1, it's always positive. Okay? From negative 3 to 1. So you're going to, and at 1 it becomes 0. So you eventually you will connect this to 0. Because remember, at negative 3, at 1, their solutions it's 0. So that's why I always connect it here and here. You will not choose negative 3 and 1 as sample point because they are eventually 0. Always 0. And on the right side, I'm going to pick up possibly number 2. Number 2 is on the right side. So it's a 2 plus 3 and 2 minus 1 squared. 2 plus 3 is 5. 2 minus 1 is 1 squared is 1. It's 5. So it's still positive. See? So on the left part, the graph is negative. Once you get this evaluation and the sample point is negative, it will imply the whole graph will be negative. The sample point evaluation is positive, means over the whole subinterval, the graph will be positive. This part is 5. It means over the whole interval, the graph will be positive. Because on the right side, there's no zero, no solution, so you don't have to bend it down. Okay, so now we have the sketch. It's possibly, we just say it's possibly like this. Well, I don't care how ugly it is, but it makes sense. It knows the relative position. Okay, so then you can see which part of the graph is above x-axis. Between -3 and 1 and greater than 1, the graph is above x-axis. They are the solution. The corresponding x interval will be the solution. So the solution set of the inequality is between -3 and 1, because at this interval, the sample test give you positive number. You need positive greater. Union from 1 to positive infinity, the right part. That is the answer. Well, this is demonstration. The important step is the following steps. So first, you find the solutions of the equation. You label them. And then those labels divide the number line into several pieces. From each piece, not these 2 points, not the zeros. From each piece, pick up sample point, simple sample point. Pick up sample point and evaluate polynomial at those sample point. Get the value. We don't really care the concrete value, but we do care it is positive or negative. If at the sample point you get a negative value, it means over the whole, no matter how big it is, over the whole interval, the graph will be negative, will be below the x-axis. If the sample point is positive, means over the whole interval, the graph will be positive. Even over the infinite interval, it's still positive. Okay, and then after you determine the relative positive and negative graphs, you can find the solution set based on the problem and the x. Remember, this is x intervals. So here the graph is above it, so the corresponding x interval is -3 and 1. Okay, so that's the method. Okay, now let's see another example. The difficult part is to find the solution of equations. So for example, assume we have solve the inequality x24 greater than x. x24 greater than x. Well, how do we do that? We first move x to the right side as x24 minus x greater than 0. And then we need to factor it. To solve the inequality, except you have formula, you must factor it and use zero product property. Okay? So here you factor out x, you will get x cubed minus 1. And remember, x cubed minus y cubed, we have x minus y, x squared plus xy plus y squared. Okay, so we continue the factorization. X cubed minus 1, 1 is a 1 cubed. So you get x minus 1, x squared plus x plus 1. Okay, so we have product. The product is So solve x minus 1, x squared plus x plus 1 equal to 0. We find the 0 first. Here we just do the factorization. This problem is simple because it's already factored. Okay, so either x is 0 or x minus 1 is 0 or x squared plus x plus 1 is 0. X is 0, then solution is x 0. X minus 1 is 0, solution is x equal to 1. And you can check that this one, this quadratic polynomial b squared minus 4ac is equal to 1 minus 4 times 1 times 1 equal to negative 3, less than 0. Discriminant is negative. This one, no solution, has no real solution. Okay, so this equation has no real solution. There's only two solutions, 0 and 1. Okay, no real solution. Two solutions, 0 and 1. So you label 0 and 1, and you have 3 branches, 3 subinterval, 3 parts. Again, this is not a graph. This is just 3 parts. Okay, and then you're going to pick up sample point from each interval. So I'm going to, for example, here I will pick up negative 1. I want to tell the difference between the solutions and the sample point. I pick up negative 1. I pick up 1/2. I pick up number 2. And when x is negative 1, I'm going to evaluate this left side. The left side is the original one. So it's a negative 1 to 4th power minus negative 1. This is complex, but it's just a factorization of the original one. So the original one is easier to be evaluated. So negative 1 to 4 is 1, minus negative 1 and plus 1 is 2. So over this part, it's plus, positive, plus. And when x is equal to 1/2, 1/2 is 1/2 to 4th power minus 1/2. 1/2 to 4th power is 1/16 minus 1/2. Well, it's definitely negative. 1/16 is less than 1/2. 1/2 is 8/16. So it's negative, so this part is negative. And when x is 2, so 2 to 4 minus 2. 2 to 4 is 16. 16 minus 2 is 14. This is positive, right? So positive, negative, and positive. So once you determine this and you check what the inequality you have, you need the greater than 0 case. Greater than 0 case, so the solution set of the original inequality is, you see, you need a positive, greater than 0. So you check here is positive, here is positive. So it's from negative infinity to 0, to this part, to 0. And from 1 to positive infinity. Okay, that's it. So you even don't need to graph it. You just put plus or minus sign. All right. So let's see one more example. So for example, we do it the fast way. Let's for example, we have on page 372, problem 20. Assume we already have this factored version. X minus 5, x squared plus 2 squared is greater than 0. So first, you solve this x minus 5, x plus 2 squared equal to 0. You get x equal to 5 or x equal to negative 2. And then you draw them on the number line. You have 3 parts, not always 3 parts, because you have 2 solutions, then you have 3 parts. And then you choose sample point. For example, here I choose number negative 3. Here we can choose 0. Here we can choose 6, whatever. So when x is negative 3, so negative 3 minus 5, negative 3 plus 2 squared, you evaluate this polynomial. Negative 3 minus 5, negative 8. Negative 3 plus 2 is negative 1. Squared is a 1. So it's negative 8. It's negative at 0. At 0. It's a 0 minus 5. 0 plus 2 squared. 0 minus 5 is negative 5. 0 plus 2 is 2. Squared is 4. Negative 20. Still negative. And on x is 6. So it's a 6 minus 5. 6 plus 2 squared. 6 minus 5 is 1. 6 plus 2 is 8. Squared is 64. 64. Positive. Okay? And then let's check. The original inequality is greater than 0. Positive. So the solution set is just this piece. 5 to infinity. Be careful. This is from 5 to infinity. 6 is a test point. It's not part of the solution. Okay? So this is our polynomial inequalities. How do you solve it? The important thing is to determine the zeros of equations. Okay, now let's see the second part, rational inequalities. Rational inequality, you see, there's one thing we all know, but possibly we didn't mention them. So fx over gx, this ratio, and fx times gx, this product, always have the same sign. They will be either both positive or both negative. You will never have one is positive, the other one is negative. That's impossible, right? Yeah. So this is a very important observation or a common sense. So for example, if we want to solve this inequality, we have two things. First, it is greater than. Second, it is equal to 0. Let's check. Let's consider them separately. Either greater than 0 or equal to 0. Greater than 0, the ratio is greater than 0. It's equivalent to get the product is greater than 0. They're either both positive or both negative. Then the product is still both positive, both negative. Equal to 0, you only get the numerator is 0. So a ratio, a fraction is 0 if and only if the numerator is 0. Denominator is never 0. So, right? So here, this becomes a polynomial inequality. This is not a rational anymore. It becomes polynomial inequality. To find the polynomial inequality, x squared minus 4, 4 is 2 squared. Remember that x squared minus y squared is x minus y, x plus y. It's an important formula. So this is x minus 2, x plus 2. And then you find the zeros. Remember, you need the solution. So x minus 1 is 0, x is 1, or x minus 2 is 0, x is 2, or x plus 2 is 0, x is negative 2. So you have 3 zeros. And here x minus 1 is 0, x is 1. But this is a solution. This is part of our process. We're not done. And then let's check. Negative 2, 1, and 2. We have 3 zeros for this polynomial inequality. And we have 4 regions. 1, 2, 3, 4. We have 4 regions. And you have more regions, you need more tests. So you're going to pick up, for example, here's negative 3. then x is -3. You evaluate this. It's a -3 minus 1. -3 squared is 9. 9 minus 4. So it's a -4 times 5, -20. So it's a negative. Between -2 and 1, we pick up 0. X equal to 0. You get 0 minus 1. 0 squared minus 4. This is 4. This is positive. Between 1 and 1/2, let's pick up 1 and 2. We get 1/2. Between 1, not 1/2, 3/2. Between 1 and 2, we get 3/2. So x is 3/2. So you get 3/2 minus 1. 3/2 squared, 9/4 minus 4. This is 1/2. This minus a negative 7/4. Well, this is negative number, right? A positive number times negative number is negative 7/8. It's negative. This is negative. X is greater than 2. For example, I choose 3. When x is 3, 3 minus 1. 3 squared is 9, 9 minus 4. So it's 2 times 5 is 10, greater, positive. All right, so we get a negative, positive. And the original inequality is about the greater than 0 case. So the solution set is greater than 0 between -2 and 1 union 2 to positive infinity. Right? So remember, we are not done. This whole part is to solve this inequality, And this is the other part when it is equal to 0. See, this is one leg, this is the other leg. So final answer should join these two solution sets. That's why I use a little box to just restrict this part here. It's just the left branch. This is the right branch. So when you unit this solution set, the solution set of this inequality only left part. So the solution set, the final solution set, the total solution set is this part union 1. Union 1 means you have to add a 1. So it's from -2 to 1, but this time we add a 1. This is difference. Union from 2 to positive infinity. Other part not change. So this is a total answer. It's a total answer. All right? It's a little bit complex. You have to transform a rational inequality to polynomial inequality. But actually, we do the similar steps. Okay? So let's see another one. Example. Solve the inequality 4x plus 5, x plus 2 greater than or equal to 3. Well, we only solve the inequality either greater than or equal to 0 or less than or equal to 0. We do not solve greater than or equal to 3, which means we are going to move 3 to the left side. We only solve this case because we only have zero product property. And then we find the common denominator is 4x plus 5 minus 3 times x plus 2. X plus 2 greater than or equal to 0. So it's a 4x plus 5 minus 3x and minus 6. 3 times 2 is 6, but it's minus. X plus 2 greater than 0, greater than or equal to 0. So it's x minus 1 over x plus 2 greater than or equal to 0. Okay, this is like the previous example. A fractional function is greater than or equal to 0. So you have two cases, either x minus 1 over x minus 2 greater than 0 or x minus 1 over x plus 2 is equal to 0. This part is equivalent to x minus 1, x plus 2 greater than 0. You change the ratio to the product, and this is equivalent to x equal to 1. The numerator is 0. And here, you see, we do the similar step. You have solutions 1 and negative 2. You have 3 branches, right? X minus 1 equal to 0, you get x equal to 1. X plus 2 equal to 0, x is negative 2. You have 3 branches. You pick up 3 test point, negative 3, 0, and 2. X equal to negative 3, you evaluate negative 3, negative 3 minus 1, negative 3 plus 2. So it's a positive 4, positive. X equal to 0, it's a 0 minus 1, 0 plus 2, negative 2, negative, right? And you pick up 2, x equal to 2, it's negative here, negative. 2 minus 1, 2 plus 2, 2 minus 1 is 1, 2 plus 2 is 4, 1 plus 4 is 4, positive. Okay? Oh. So the solution set of this branch, of this one, the solution set is, we need a positive, so it's from negative infinity to 2, negative 2, my bad. Negative infinity to negative 2, union to union 1. Be careful, I always make such mistake. From 1 to positive infinity, from 1 to positive infinity, okay? So this is just the solution set of this branch. You have to union it with 1. So the total solution set is negative infinity to negative 2 union 1 to positive infinity. Here is round, here is bracket. And that's it. That's it. Okay? So rational inequality will be solved based on the polynomial inequality. You always look for the 0 first. You look for the 0, you label the 0, you put a test point, and you check the sign. And based on the sign, you get a positive or negative. And be careful, you can only compare it with 0, greater than equal to 0 or less than equal to 0, which means you have to move everything to the left side. Don't leave any non-zero term on the right side. All right? And after you get the solution of this polynomial inequality, you have to check if you need to join additional point or not. If it has greater than or equal to 0, possibly you will join some additional solutions. If it's just strictly greater than 0, then there's no this part. Okay? Okay, excellent. So do your exercise. If you have any questions, send me an email. If you find any mistake, also let me know. Thank you very much. We finished the lecture.